show you how to wire a boat. So this is a pretty common setup right here. We have a LED for a load, and we have the basic Chinese switch that is all over the internet, a 12-position fuse panel, and then a certain way to isolate your battery. You want to make sure that no power can be pulled through your battery through parasitic loss or the possibility of leaving something on. So having a battery shutoff switch works well. But another acceptable way to do it is to use a 60 amp or 50 amp breaker. One pro tip I would like to give is never to include your outboard power through your battery shutoff switch, but everything else goes through this terminal. Now our main line is going to be a heavy wire that supplies power to our fuse block here. So probably a 10 or 12 gauge. It's going to lead up to your helm and supply power. You have to think of power running through wire as a highway system or an infrastructure. The bigger the highway, the more cars it can handle, right? Well, the bigger the line of wire, the more amps it can handle. So you want to make sure that you have a heavy line going in, and then each line that comes off will be slightly smaller. So on our fuse panel here, we have a line down here, and this is our common rail ground. You can see that both of these leads, positive here and negative here. This negative is just for this area, and this positive has two main bus bars that runs down through here. These are great if you don't exceed 10 amps. If you have anything larger than 100 watts, you need to go ahead and make sure that you're using a relay system because these simply can't handle the load. Now the center divider means that one side is negative and the other side is positive. Never put positive and negative on the same side and you'll never have a problem with a switch. So we have our ground that goes to the bus bar on our negative side of the fuse panel, okay? And then our negative goes back to the battery. But the other side is positive. We need to put our positive in the middle, and you have to think of this as like a teeter-totter. Right now, this is not connecting to here, okay? But if we do this, it will, and that's on both sides. So that makes this our power in, and this is our accessory out. And at this point, I need to go ahead and finish up this wire lead, put it right down here. Now we have a complete system, okay? We have the negative side, which is only for the negative part of our LED. We have a positive coming in from the fuse panel, and we have a drop, which goes to our accessory, which is our light, okay? Green means we're powered, and then we have a 5 amp, which is plenty for this little LED. But at this point, we can go ahead and hit our switch, and the light comes on our switch, and our accessory is working. Now, if you ever go to the switch panel and you turn it on and your light isn't working and the accessory isn't working, that means that your fuse is blown. Let's simulate that now. So now our fuse is blown, we'll say it's bad, right? And since this is a complete circuit, this particular fuse panel has an indicator telling us that we have an issue on that circuit and we need to replace the fuse.